Okay, so here is the second video for my ketones where I go through McLafferty rearrangement. I know several of you have been waiting for me to make this. Well, it's here now, okay? All right, just like with our alcohols, McLafferty rearrangement does have a requirement. With our loss of water with alcohols, we needed a gamma hydrogen. We still need a gamma hydrogen with our McLafferty. And just as a reminder with ketones, the alpha position is not going to be the carbon on the oxygen. With ketones, the alpha position is the carbon next to the double bond. And this double bond specifically is called a carbonyl. So alpha, oh, I had some space. So alpha is going to be carbons bonded to a carbonyl carbon. All right, so I have two alpha positions here. I have two alpha positions in this example as well, but only one side gives me a gamma. So I did this was from my class notes, but here's alpha, there's my beta, there's gamma. So I actually have 3 gamma hydrogens here. I only need 1 from McLafferty, so we're good to go. Okay, so let's go ahead and start showing these arrows. Now, I always tell you have a video, so you can hit pause if you need to take a minute and all that stuff, but I do always tell my students, just watch me do it the first time before you try to take notes. You have a video, you can hit replay, that's allowed. All right, so again, just like always, I'm going to use that radical to get me started. We did find the molecular ion peak for this ketone in the previous video. It was 86, so I'm just going to write that down again. So my molecular ion peak here was 86. Now let's see how this works. So just like our dehydration, I'm going to have an arrow that kind of goes in the middle of nowhere, but it's okay because I'm going to have another arrow meet it. That is moving that hydrogen to the oxygen. Now I have another electron in this bond. What it's going to do is instead of going to the gamma carbon like it would in dehydration, it is going to start the process of forming a double bond between my beta and gamma carbons. Yes, it will always be between my beta and gamma. To finish that double bond, I'm going to take an electron from the alpha-beta bond, and then I have 1 electron left in that bond. That will form a radical on the alpha carbon. So I get asked this a lot. Yes, it will always be alpha that gets the radical. Yes, it will always be beta and gamma that get the double bond. Okay, so let's draw what we just did. So my methyl group on the left side is still there. I do still have the carbonyl. Now this has picked up a hydrogen, so I do still have a positive charge here. And I do still have the alpha carbon on the right side. It now has the radical, but I broke the alpha-beta bond. So I no longer have a beta, and then beta and gamma are now a double bond together. And that's it. So that is what I have drawn. This will be the species that has the mass to charge ratio because it has the cation. Just like dehydration, it just so happens to also be the fragment that has the radical. So now I'm going to calculate our mass to charge ratio. Well, I can kind of figure out this one a little bit faster. So I can figure out the mass of this and just subtract it from my molecular ion. So 86 minus 2 carbons is 12. And then those had 2 hydrogens, so plus 4. So 86 minus 16. And I'm going to get, is that 70? I think that's 70. All right, this is how low confidence I am. All right, so I have 70 here. So that's what I would expect to see from my McLafferty rearrangement. I'm actually kind of worried about that. So let's see. All right, yeah, I thought it was a little bit off. So let me double check by actually doing the real math. So 16 plus, I have 3 carbons is 36. I'm doing a lot of math today. 36, and then I should have, okay, 3, 5, 6 hydrogens. Okay, so 16 plus 36 plus 6, 58. Oh, I was way off. Way off. Okay, so that should be my McLafferty mass to charge ratio. Okay, why was I so off on that? Interesting. All right, so let's look at our mass spec. So that's actually what I would expect to see. Let's erase the 70. I had a feeling that was wrong. Okay. So 58 All right, that makes a lot more sense. Okay, so let's see. We have our molecular ion peak here. Then, okay, what's this guy above 70? Let's see. Oh, that is going to be from my alpha cleavage here. So that is the alpha cleavage. And then I see 58 from my McLafferty. And then I bet that other one is from my alpha cleavage, so 43. Yep, so that is my 43 also from my alpha cleavage. So I do see the expected fragmentations for this ketone. So I have enough that I've convinced myself that this is the mass spectrum for this structure. All right, so I hope these videos were helpful with looking at arrow pushing with the mass spec for our different functional groups.